Hello, my name is Scott Sheeter. I'm a principal engineer at Slipstream. The topic of this video is an advanced lighting control strategy called task tuning. This video is part of the ESTCP Advanced Lighting Controls Technology Transfer video series. I'll begin by describing what task tuning is as a control strategy and the importance of incorporating occupant feedback, followed by a brief discussion of potential task tuning opportunity for a sample set of space types. And lastly, I will identify some best practices for integrating task tuning into the design or redesign process. Task tuning is setting a fixture's maximum light output to something less than 100%, often in response to a space that would otherwise be overlit, or as a means to reduce glare. It is also sometimes referred to as institutional tuning or high-end trim, but for the remainder of this video and others, we will refer to it as task tuning. So how does task tuning save energy? Here we see the light level produced by an idealized lighting system as a function of its power. As you can see, as the lighting power increases, so does the amount of light in the space. For this idealized untuned lighting system, you would measure 50 foot candles of electric lighting, while the system uses 500 watts of electricity. For this example, the recommended light level per the Illuminating Engineering Society is 40 foot candles. Tuning adjusts the lights to those recommended levels, resulting in a power reduction of 100 watts. That was instantaneous power savings, but how does this play out in terms of energy savings? Here we see a plot of our idealized example system's lighting power consumption over a typical day. Note that this system does not have daylighting or occupancy controls. In the morning, the lights come on to their full power and remain there throughout the day before being shut off manually at night. After tuning, the lights still come on at the same time. However, they now come on to their tuned power instead of their full power. The difference in power savings summed over time is the energy savings. An important consideration when implementing task tuning is occupant comfort. Because task tuning is essentially a trade-off between energy consumption of a lighting system and light levels in a space, it is important to balance energy savings with occupant visual comfort. Light level reductions that are too aggressive may result in high energy savings, but at the expense of occupant satisfaction. Complicating this balance is the fact that occupants perceive light levels differently, both among individuals and under varying situations. Because of this complication, we recommend incorporating occupant feedback into the task tuning process in order to strike the right balance between energy savings and occupant visual comfort. Although this may result in lower immediate energy savings, it's likely to increase energy savings persistence, as facility managers will be less likely to override tune controls because of occupant complaints. Anecdotally, you may be surprised to receive feedback that an even lower light level is preferred, as has been the case in several instances across various demonstration projects. To quantify the magnitude of potential energy savings and light level optimization, I'm going to refer to some of Slipstream's research findings from a lighting characterization study conducted in Minnesota. This characterization included site visits to accurately measure light levels in a representative sample of space types, where LED retrofits had occurred. We compared and measured light levels or luminance levels within industry standard recommendations as defined by the Illuminating Engineering Society. It's important to note that the Unified Facilities Criteria recommendations or requirements are based on the IES light level recommendations. Summarized here are mean measured values, IES recommended illuminance values, and the task tuning percentage. The task tuning percentage is the maximum lighting power limit. Note that implementing a task tuning percentage of this amount would bring the actual and recommended light levels into alignment. You'll note that for all space types, the mean measured illuminance was higher than the IES recommendation, indicating in several instances significant opportunity to both capture energy savings and improve lighting quality by minimizing the potential for glare from overlit spaces. However, care should be taken when implementing task tuning to understand the user needs of a given space. We'll get into that more shortly. It is also possible to incorporate task tuning into the design or redesign process. lighting practitioners regularly use photometric analysis, which is completed with computer modeling software, to estimate light levels or expected illuminance values based on a specific fixture and the layout of the fixtures within spaces. This image is an example of a point-by-point photometric calculation. Overall, photometric analysis does a good job of estimating light levels and is quicker than field measurements since it does not involve lengthy site visits. And since it is already a part of many projects, service providers could rapidly deploy it for quick determination of light levels and corresponding task tuning set points. Additionally, UFCs require the completion of photometric analysis to confirm light levels are consistent with UFC requirements. Photometrics are often offered as a free service by manufacturers, distributors, and lighting sales representatives. Contractors can readily access this no-cost resource, and design teams typically employ staff not only capable of performing this task, but that regularly utilize photometric analysis as a part of their typical design process. Computer modeling software used to generate point-by-point photometric analysis also typically summarizes those results in a tabular fashion like shown in this image. These tabular results describe various parameters that guide lighting design decisions, including the estimated average illuminance or light level. These results are a useful tool for identifying opportunities to optimize light levels via task tuning and capture the associated energy savings. This is an example of a control matrix that was created to illustrate documentation of lighting control design intent, which encourages the completion of photometric analysis during a project's design phase. This type of documentation is not standard practice for many retrofits, so must be requested by a facility manager. In this example, the task tuning percentage is identified in the column on the far right. Again, this is the maximum lighting power limit. In a Department of Defense demonstration, which will be the topic of another video, we found the implementation of task tuning to be most successful when implemented using this strategy. Alternately, light levels can be measured and adjusted during installation and setup, but this approach was found to be more time-intensive and the implementation itself to not be a priority for personnel involved in configuring the lighting system. A control matrix or schedule of some kind, which details the lighting control design intent, can be easily incorporated into design documents and ensures that a contractor has a clearly defined scope that must be implemented during the construction phase of a project. If field measurements are needed to confirm target illuminance values have been achieved, or to investigate existing light levels prior to a retrofit, there are some best practices to keep in mind. The light meter should be placed on the work plane or held away from your body so that you do not cast a shadow on the sensor. It's best to record measurements at a location where tasks will be performed, not in corners of a space and not directly below a light fixture. It's also important to capture the contribution from electric lighting only, which can be done by either recording measurements after the sun is set or by recording the difference between measurements taken with blinds closed and lights on, followed by blinds closed and lights off, and then subtracting the two values as illustrated by this simple equation. This brings us to the conclusion of the video. More information on this topic is available both on Slipstream's website and on the Design Lights Consortium website. The DLC also maintains a qualified product list of network lighting controls and luminaire level lighting control systems that are capable of task tuning, as well as other advanced lighting control strategies. Thanks so much for watching.